Hello, good afternoon. I have to say I'm quite impressed with seeing you all here so late and the very last day of FinOps X. Kudos to everyone for your dedication to develop and to learn from established peers and industry leaders. Now, knowing that we're probably the last thing before your fun conference party tonight, we'll dive straight into it. I'm Irena, Engineering Manager Infrastructure at Canva. I'm based out of Sydney, Australia.
And I'm Japan. Yep, my name is just like the country. And I'm a software engineer, infrastructure, and FinOps at Canva. And I'm from Melbourne, Australia as well. So together, we'll delve into the world of unit economics and beyond.
In particular, we'll share how we dive deep into our microservices costs and how the insights helped Canva with decision-making, product strategy, ROI, and of course, cost optimization. A little bit about Canva. It was founded more than 10 years ago to power all visual communication needs and is now one of the most widely used platforms on the internet. It's used by more than 95% of the Fortune 500 companies. Design used to be complicated and hard. So we wanted to make design so simple that anyone, regardless of their skills or ability, can have an idea and turn it into a design within minutes. Our mission has always been to empower the world to design, and we are now accelerating it with AI. AI is now deeply embedded across every single layer of our organization and our product. But we're all numbers people here at FinOps X, so please allow me some vanity metrics. Our community has created more than 40 billion designs so far. Just for the last 2 minutes that we've been talking to you, more than 60K designs have already been created because visual communication is the status quo today. Today, Canva is used by more than 260 million people designing each month. Our platform handles more than 1.2 million requests per second, and we run more than 1 million vCPUs at any given hour. We have more than 500 petabytes of media under our management. Canva is a content company at the end of the day, and this is growing rapidly every day. But this wasn't always the case, so let us tell you how we started. In the early days, Canva was more focused on shipping features rather than necessarily optimizing the value of technology. But as we scaled, our cloud and AI costs skyrocketed, all for good reasons, of course. Yeah. So then we all started asking, how do we keep Canva efficient at scale? This is when our FinOps practice was born about 3 years ago, starting with a massive team size of 2 engineers sitting under our infrastructure organization. We wanted to start simple, like most of you have done here. We wanted to take cost data out of hidden infrastructure-specific sources and share it widely within engineering and finance. In order to do that, we had to overcome a few cost allocation and visibility challenges. We built our own custom data pipelines, custom cost dashboards, and we started sending monthly cost reports to all leaders at Canva. We introduced tagging. Teams took ownership of their own costs, which sometimes led to up to 50% cost reduction in certain areas. From there, we introduced a few more technical, organizational, and process shifts. For example, we started using dedicated processes and products in order to manage rate optimization, which led to a sharp increase of our effective savings rate. We built a virtual FinOps team with representatives from finance, from procurement, of course, engineering. We added data engineers to the team, and that team now grew to the size of 8. At that time, we were serving more than 3,000 internal customers, or Canva nuts, as we like to call ourselves. And a magical thing happened when we gave engineers visibility of their costs. They naturally started optimizing. With that, we introduced the Cost Efficiency Heroes program internally, which rewarded teams for their cost and usage optimization effort. We also embedded cost considerations into the design of new systems. And then later on, we realized that cloud was obviously just the beginning of it all and just a piece of the puzzle, so we added SaaS and AI providers to our pipelines. And then we started asking, what would be a meaningful data to each of our internal teams? So how do we bring costs even closer to them?
We quickly realized that showing a team an absolute number like $1 million bill is very not helpful. Without context, team would simply say, hey, we are scaling, so of course our costs are up, right? To solve this, we had to take the scale out of the equation and focus on unit economics. We started simple. We moved beyond just the initial cost per monthly active user, and we partnered with infra teams to define cost per CPU, cost per AI token, storage, as well as cost per microservice. These metrics helped us notice trends, set realistic cost goals, and improving pricing estimates. However, we hit a new wall. A single user click on a Canva UI can trigger multiple backend services. We have costs for all microservices, but we don't know which user interaction is driving the cost. And with the launch of AI-powered features, it accelerated this need. AI features provide incredible value, but comes with a very significant cost profile. If a microservices cost spike, we needed to know exactly which AI function or user interaction was driving this. We realized that to truly manage cost in a platform as complex as Canva, we had to dig deeper than the microservice level. We needed to map cost directly to the user interaction or features. Essentially, we needed a new dimension for cost visibility.
So this is how the concept of cost per feature was born. At Canva, our products are made of many features. You can think of a feature as a single action initiated by the user. For example, generating a design or removing the background of an image. We have about 250 features at Canva. Previously, product owners really only had general vibes of their costs. They had just general understanding of costs, but no hard data. And as everyone here knows, if you have no visibility, there is no way to measure, and there is very little incentive for teams to optimize. The situation snowballed with the rise of AI. For example, we figured out that with our Generate Design feature, whenever AI model inference was involved, the cost was about 7 times higher compared to interactions without it. And as AI features became more and more relevant, our FinOps team found ourselves just trying to answer more and more questions that were outside of our usual infrastructure engineering domain. For example, product managers wanted to know whether feature engagement justifies the cost. Leadership needed data to help guide decisions on prioritization, investment, or sunsetting, as they wanted to spot expensive and low retention features early. Engineers wanted to know which features architecture to optimize first, and then finance needed a breakdown of free versus paid users to overlay on top of their cost forecasts. Now, these questions all came from the same problem. There was a gap between our business goals and infrastructure metrics. Specifically, how much does a feature, like for example, the Generate Design feature, actually cost Canva? Japan, give us some more details about how it works.
Sure. Let's now deep dive into how we implemented cost per feature. So internally at Canva, we store all our metadata about our features in a system we call feature catalog, which holds key information like key information metrics like retention, adoption, performance, growth, and many other business metrics. As I mentioned, a single feature can span across multiple microservices, and currently we do have costs attributed to microservices, as you can see on the left. But you see those question marks on the left as well, that even though we have the cost of the microservices, we cannot attribute cost to the feature, like which features are driving the cost of the underlying microservice. So we wanted to go beyond this microservice cost and assign this to individual features. Now, this is something we can see on the right. What we're trying to do here is basically for a feature like generate design on the right, we want to derive the cost of this feature from all the underlying microservices, AI services, and other functions. Now, we have 250 features registered in our feature catalog. And if we do expose this technology right next to the rest of the business metrics, we can truly have the cost to value comparison. So how did we start this? Well, we found that we were already tracking a lot of the telemetry data, which is collected for every user interaction. And this is what powers the feature catalog metrics. Our plan here was to utilize trace data.
Hey, Japan, does everyone here know what trace is?
Good question. One of the types of telemetry data that we store is traces. Trace is a single digital trail for a single user request, showing exactly how it's moving through different microservices and database in our system. So we had trace data, and we also have feature association data. This is the link that connects the traces to the features so that we can have trace data mapped to the features in the feature catalog. And lastly, we also have cost data. This is calculated for microservices. This is basically the cost of the underlying cloud resource or the AI builds that gives us the actual dollar cost. Now, we have the telemetry data and cost data, so all we're trying to do here is combine this data to bridge the gap between the business metrics and infra metrics. So if we zoom in a little bit on the trace data, for every interaction on the front end, we can see multiple backend services are getting spawned. When a feature will interact with this microservices, we track this with a trace ID. Now, this is the unique trace ID for every user interaction, and the time it takes to move through this microservice, we track it with span. And in some cases, things are done async, like queuing an AI call to our AI model, in our example. Then we use a different trace and its own span. So in our example of generate design feature, where we do use AI model, this could be as simple as when a user clicks on generate design on the UI, as the trace goes through different microservices, it assigns a trace and the time it takes to design, like generate the design. And it waits for the async call by queuing with our AI model, and then it has its own trace ID and its own span as well. On the other side, with a simpler feature like just adding a new page to a design, we don't need AI, we don't need any crazy microservices for that. In this case, we just have the trace ID and a span to actually the time between it creates the page. Now, with the trace data available to us, we had this normalized by our observability platform, and we are associating costs to the type of infrastructure. So for compute, essentially, we are using time to slice up the bill. First, we calculate the total time spent on a specific microservices, and then determine what percentage of that total belongs to a single trace. We then take the actual cost data from our bills for that service and apply a percentage to find the trace specific cost. Essentially, if a trace accounts for 10% of the microservice cost, then we assign 10% of the bill. What this does is it also removes any of the idle cost from the feature cost. Now, some of you might know that calculating compute cost by time is not always perfect. In some cases, like an I/O bound services, a call to an I/O would actually include in part of the compute cost, which is not something we want, but it works in most cases, And because we are using this cost per feature to give us directional insight, I think we can live with this one for now. And for our AI services, unlike compute, we don't get billed by time. Here we have fixed token counts. And from the AI billing data, we simply multiply the token count versus the unit price to get cost per trace. Now, with cost per trace all calculated, we just have to enrich this cost per trace with our feature data. And this can be available in our feature catalog.
So just to summarize what Japan just shared, and to put it simply, we collect traces for every user interaction on front end, then multiple microservices usually fulfill that request. We have the trace data available in our observability backend, and then we assign cost per trace based on resource usage like compute or AI. We then enrich this cost per trace data with features data from our features catalog, which gives us cost per feature.
Now, I would love to tell you this process was almost smooth, but it wasn't. So let's look at some of the interesting challenges we faced. We saw that at Canva, for a given month, we have roughly 60 billion user interaction across 250 features. Now, this is a lot of data if you try to ingest this. Essentially, if we did do this, we would be spending more time and money just ingesting this data than the actual cost of these features. So we did some investigation, and we found that our observability backend was already only keeping 5% of all traces that were reaching our microservices. Now, we can retain this 5%, but it's still a lot. So we did a bit more investigation, and we found that to truly solve this business problem, we only need 1% of the traces. With the 1% sampling rate, we have enough sufficient statistical features and more data, more manageable data volumes for us to use, and a significant reduction in storage cost. Another challenge we had was, since our observability platform was already applying a sampling filter on traces, when a user action triggers a multiple linked trace, which is incredibly common in async workloads, the sampling filter might capture the parent trace, but it might discard the child trace, or vice versa. Now, this created an incomplete trace chain, which you can see on the top image, and it made it impossible for us to attribute cost to these features. Now, to solve this issue and to remove the bottleneck, as we see in the bottom image, we migrated to a simpler one-table trace pipeline architecture. What this did was completely remove the secondary processor sampling at the observability backend level. So by preserving this trace chain in this one source, we ensure that if a parent trace is sampled, then its linked traces, child trace in this case, are also sampled too, which allows us to accurately measure backend cost for this feature. Now, Irena, do you want to tell us about the rollout that we did?
Yeah. So now that we had the solution ready, we wanted to share how we planned to roll it out. We didn't want to roll out this to all of our features at once. So instead of rolling out cost per feature to all of 250 features as a big bang, we chose 28 high-impact features as a pilot group. This phased approach allowed FinOps to test our cost attribution model, allowed us to show early value to our stakeholders, and also allowed us to receive feedback and incorporate it as we go. Now, the first selection criteria for these 28 features was cost magnitude. So we intentionally targeted features that we thought might be the most expensive for the company. The other reason why we chose high compute and high AI features was because we needed a high volume of backend data to prove our methodology. So whether that was Kubernetes or expensive AI APIs, we needed a meaningful volume of data just to make sure that our methodology is right. Our next selection criteria was feature complexity. So we targeted features that had a simple start and end state, like clear and unambiguous. We asked, does a feature have some kind of complicated dependencies or unclear end state? If yes, we deferred it. We wanted the initial instrumentation to be as straightforward as possible. Finally, we looked at team capacity for our and stakeholder value. This was a very important criteria. We specifically evaluated if the teams that owned these 28 features actually had the bandwidth to engage with us and provide feedback. We wanted the early adopters to consider cost optimization as a priority, just so that we can ensure successful end-to-end engineering partnership. So here we are today, after a bunch of research, trial and errors, and overcoming multiple organizational and technical challenges. We now merge raw trace data with billing logs in order to follow a single user event, like a single click, and actually attach a price tag to it. By understanding the true margin of a single user action, we can evaluate ROI, make informed decisions, and build towards improving our margin. Worth noting that because we don't yet cover every single infrastructure resource, and because we utilize sampling, we think of this as a tool for directional insights. It's perfect to incentivize product and engineers to improve efficiency and optimize, but it's not yet meant to be a precise financial line item accounting item just yet. And with this new data dimension that the FinOps team is now providing, we can now go back, and Canva as a whole can go back and answer all these questions that were asked by our stakeholders initially. So now product managers and leadership can look at feature costs and weigh that against retention. Finance can now overlay free versus paid users' data on top of their cost forecasts, and engineers have a roadmap of what features architecture to optimize first. So we've piloted this across a selection of key features, and this is how the cost data actually looks in our features catalog tool.
Throughout this process, we learned a few valuable lessons. One of the lessons we learned was, instead of reinventing the wheel, we actually looked at the existing organization that we have, and we found that we can leverage the existing telemetry infrastructure rather than building our own ones. We also found that our users love feature catalog. This is where all our business metrics are. So instead of us doing our own FinOps thing, we should put the data where our customers are or engineers are, rather than creating our own FinOps silo.
That's a good point, Japan, thanks. Another lesson learned was around avoiding perfectionism. Probably everyone here knows that perfect is the enemy of good. Initially, some of our stakeholders over-focused on just technical accuracy versus pragmatic utility, but by showing them the early data, we were able to soon convince them of the value of the initiative. Even though cost per feature produces just approximate numbers, it is perfect to, again, to allow us to compare business metrics and cost for features. And probably the biggest lesson learned of it all is how a group of 6 engineering teams within data, finance, platform, and observability together were able to solve a board-level business problem and fundamentally shift how we work as a company. Previously, we tracked engagement, but we couldn't quite tell the actual ROI of a feature. Now, product and leadership can look at a granular daily cost trend data and actually be able to say whether, again, the feature is worth investing in. It changes the conversation from, look at how many people use this feature, to, does the adoption and the revenue of this feature actually justifies its infrastructure costs? It allows us to make smarter decisions about pricing, packaging, and where to invest our engineering resources.
Now, if you are interested to explore this yourself, I would say register your features by formally defining and cataloging this before instrumenting anything. For this, you can talk to your product managers for the definitions and the ownership. And then instrument the front end by attaching a unique ID for any interaction that you care about via or your own observability SDK by talking to your client engineering or front end for SDK instrumentation. And then this is the big one, which is enforcing a backend discipline by propagating the feature context through a standard OpenTelemetry standard across boundaries. And for this, you can talk to your backend and microservices engineering team for span propagation. And then socialize these outputs with your finance team for forecasting and budget alignments, and your product and leadership for ROI and prioritization decisions. But something I would say is, if you see the left side, that's the easy part, solving the problem. The hard part is getting these personas to talk to each other and getting them on board with this plan. Now, looking ahead, we got great feedback from our product managers and engineer alike. And for us, after this talk, this doesn't end here. So we are continuing to expand cost per feature capability. We're working with the feature owners to roll out the capability to all features in the catalog. We're making UI improvements so our engineers can deep dive into cost drivers, and product managers can still retain the bird's eye view. And we're expanding the scope to the infrastructure to include service categories like storage. And we're working to actively identify and prioritize cost optimization.
At Canva, we like to say that we're only 1% of the way there. And cost per feature and our FinOps practice is no different. There is a lot we want to achieve in the next few years, and we definitely believe our FinOps practice is a journey, as we heard from a lot of the speakers here in the last 2 days. We hope these examples helped and even inspired to take an action and continue to optimize the value of technology.
And with that, we just want to say a huge thank you to FinOps Foundation for having us today, and all you great audience for having us here. And we are open to live questions now.
Right. Should I toss?
So fun. How do you avoid days where you have idle capacity from making the features look like they're inflated?
When we were sampling, all our features are actually, like, based on the user interaction, we have traces. So if some feature is getting used a lot more, we have more of those traces, whereas a low usage feature will have less traces. We then take these traces and then obviously apply our filtering and things like that, and then you have the statistical variances and all that takes care of that. So even though we track 1%, we kind of just assume the 99% is probably the similar.
No, I mean when you're reallocating the idle capacity, and some days you're going to have more idle capacity than
Yeah,
others.
so right now we don't allocate any idle capacity because we take the trace and then apply our cost, like as I mentioned during the compute, like when we have the traces for a given percentage of the microservice cost, we already take out the idling from it. So we never see any idle cost go back to the features. Currently, the idle cost just sits there for the team.
Behind you.
Okay, so I had a question on the front of, did you avoid, I think you said you took simple events or like kind of features with simple events. So kind of you took away the features which required AI, like?
No, for example, again, generate design feature, the one that interacts with AI models, inference, they are also included because it's a single event from start to end.
No, but then the usage for that would have gone outside? Do you have your own inference, or is it going out of your?
Sorry, which usage do you mean?
So, for example, if your feature is making a LLM call, so how would you account for that cost?
Yeah, I think Japan covered
Yeah,
it.
we already have the AI cost already allocated to teams based on the token counts and obviously the tag-based approach. So the AI cost is already attributed to teams, and then it just becomes like based on the traces, we then take that cost and associate that to the features.
Okay, so you're kind of spreading it out, but equally across?
Yeah, like we have our own cost allocation framework and also reallocation framework for our shared models and stuff like that. So we have this mature like cost allocations that is already associated teams and applications internally. What we're taking is basically taking different sections of this cost and assigning it to the feature. So the AI cost is already included.
Thank you.
Hello, great talk. Thank you very much. So I just wonder, do you have, you selected 28 features, and I was wondering if you have any core components that use multiple, that are used by multiple features or multiple products, where you were trying to attribute cost and were unable to because you just didn't have the full picture of traces and what was using that, right? If you're not attributing the idle cost and you could only sample, you know, these features coming in, how did you handle the cost allocation model on those core components?
Yeah.
And
Happy to take that. So yeah, as we discussed during the looking ahead slides, for example, storage is one resource that we don't yet capture, so that would be a great example, a feature that is really heavy storage feature. So yeah, at the moment we don't include that just because it's, again, there is a lot of considerations when you have to split the storage and like which feature writes a file and reads a file. But yeah, that's the next thing that we want to work on. At the end of the day, we want to start simple and not overthink it. There'll be some kind of a policy that we'll come up with that says, okay, this feature reads or writes or uses storage in a particular way, which we'll implement at the beginning, and then we'll, of course, iterate on it.
Thank you. I might just ask a follow-up question, if you don't mind.
Yeah.
Have you seen any benefits of delivering these unit metrics that you didn't see initially? You know, whether it was optimizations that are now clear, and if you did, what were they?
Yeah, definitely. I don't know if we can share the particular details, but yeah, at the beginning there was a lot of discussions around feature engagement. The product managers would come and say, look at how many people clicked on this and used it, but then it was unclear how much that actually cost. So now the conversation changed to be, well, does the adoption and the revenue of this feature actually justify its infrastructure costs? So we've definitely had a few good discussions, but yeah, without going into too many details there. Yeah, it's again a great conversation starter. I think someone here. Yeah. Good catch.
Thank you for the talk. My question is, like, you choose using a trace, like OpenTelemetry has many different, you know, they have a metrics as well. So what made you to choose trace to approximate the usage instead of, have you considered metrics, and what's the limitation there?
We had the trace data that was already powering a lot of our business metric, which already our engineers were used to. And these traces were part of the current business value propositions, and all of our product managers were already using this to see. So what we did was just take that existing data, which everyone knows, at Canva, then we just associate cost to these traces.
Right. But have you considered using, like, you know, in engineering system, they collect a lot of metrics. Have you considered using those metrics data?
Yeah, we are considering this. Like for us, this is just a pilot, but we're basically taking the feedback from all the engineers and then investing more. Because we haven't rolled this out to at least 90% of our features in the catalog.
I had one question about your sampling. So you had 1% of sampling of the total number of clicks that were made on a given feature. Did you sample the cost as well, and how are you getting the cost numbers? Are you getting it from your internal cloud or your on-prem, or is it a CapEx that you're taking as cost? How are you getting the cost, and how are you sampling it?
Yeah. As we mentioned at the beginning, we have custom data pipelines, custom cost dashboards. So all of that is already a problem that we consider solved completely. We allocate, again, AI costs, cloud costs we don't have on-prem at the moment. But yeah, all of that gets allocated to teams. So the cost per trace was already, the cost was allocated based on resources like compute or AI usage. And then that made it natural to, so basically when we needed to find the cost per trace, we already had that data.
Okay, so you already had the cost per trace number, and then you only took the sample data and the sample cost.
The cost is not sampled, the cost is the real cost.
Real cost, okay.
Yeah.
That's good. I had one other question. Did you use AI tools to develop this?
I think we heavily use AI as developers, as engineering teams at Canva, so 100% yes, but it wasn't like it was vibe coded or anything like that. Okay. Obviously, a lot of our systems are high throughput, high reliability, so at this point in time, again, we rely on it a lot in order to support us, but not to develop major systems and tools.
Okay. I was curious to know if the cost to do this traceability is justify doing the traceability per feature.
Given the number of events and features and how much interactions we see from user, even this feels, so far, it feels justified, but we will consider this in the future to see if actually it makes sense to.
Hi, thank you for the session. It looks like you all are ahead in the game to really look at cost per token or tokenomics, as they call it, and tie it to actual usage and trace it back to teams. How do you tie, or have you tied business value outcome for these costs?
Yeah, great question. Obviously, as you pointed out, we started with just reporting on cost per token, just so that we can, give product and the business kind of an idea of what, how much costs what. The next steps here are, just modeling AI costs and the reporting that I mentioned. Canva also has first-party models, so we develop models in-house, so we want to trace the cost per model generation for our own models compared to Claude and all the other third-party models, just so that we can obviously continue improving. This is in our roadmap and something that we'll be looking at next. But yeah, in terms of value, I think this is where we see the value. So by knowing the cost of using our own models, then we can improve our pricing. So maybe we change how we charge customers. We can improve packaging, obviously, so all the product lens, and also we can decide where to invest our engineering resources. So I think from that perspective, the value is already there.
Sounds good, thank you.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.